This is Mr. Martin. These are video notes for Pre-Calc Advanced. We're in Unit 6. This is the fourth video that we're talking about graphing secant and cosecant. We just looked at a secant example, so let's take a look at a cosecant example. Remember, what we want to do here is, if it's a cosecant, we want to just pretend that it's a sine curve. And we'll start doing the problem like it's a sine curve, and then at the very end, when we draw in our graph, we'll take into account that it's actually the reciprocal and draw that in the graph accordingly. So my A is -5, my B is going to be a half, C and D are both 0. We'll talk about the domain in this problem, but not very often. So if you recall, in the cosecant graph, we had these asymptotes anywhere that the cosine was undefined, which was where the sine was 0. So we're going to have all real numbers except x cannot equal certain values. So in this case, x cannot equal multiples of pi, so we write that as pi k. And then the range, again, I don't care how you write this, I'll write this in interval notation for this one. We're going to go from -infinity to my amplitude is going to be 5, so I know I can go from -infinity to -5. Let's change that to a parenthesis because we can't quite get to -infinity. We'll put that as a bracket. And then from +5 to infinity. Alright, amplitude is still absolute value of A, so that's going to be 5. My period is still 2 pi over B, so that's 2 pi divided by a half, which is 4 pi. Phase shift is C over B, that'll be 0. Vertical shift is D, that'll be 0. And my distance between key points is still period divided by 4. 4 pi divided by 4, which is pi. So here's my x values that I'm going to plug in, and we're going to just find these ordered pairs based on the fact that this would be sine -5 sine 1/2 x. Again, we'll just graph the cosecant in the very last step when we start graphing everything. There's no phase shift, so we're going to start at 0. My distance between key points is pi, so then I'll go up by pi. So pi, 2 pi, 3 pi, 4 pi. And then again, I'm going to go through this rather quickly. If you have questions, make sure that you ask. We're just going to be using the unit circle, and now we're going to be using the y coordinates. So I'm going to use the 0. Up at pi over 2, I have 0, 1, so I'm going to use the 1. Over at pi, I have -1, 0, so I'll use the 0. Down here at 3 pi over 2, I have 0, -1, so I'm going to be using that 1. Okay, so -5 sine of 1/2 times 0, so that's -5 sine of 0, which is -5 times 0, sine of 0, which is 0. -5 sine of 1/2 pi, -5 sine of pi over 2, so that's up at the top, so -5 times 1, or -5. -5 sine 1/2 times 2 pi, so that's -5 sine 1/2 of 2 pi is pi. Again, I'm going through these calculations rather quickly. If you need help on that, make sure that you get that for me. So -5 times 0 is 0. -5 sine 1/2 times 3 pi, so that's -5 times the sine of 3 pi over 2. So that's -5, 3 pi over 2 down at the bottom. My y coordinate is -1, so that's +5. And the last one, -5 sine 1/2 times 4 pi. That's -5 sine 2 pi. -5 sine at 2 pi is 0, or 0. So I have my ordered pairs. I'm going to go ahead and graph these. So I have 0, 0. Let's mark my graph here. We'll go every pi. So pi, 2 pi, 3 pi, 4 pi. And then we'll mark in enough to do 2 periods. Again, I don't care if you go 2 to the right or 1 right and 1 left. And I need it up to 5 and down to -5. And then my first point was 0, 0, and then pi -5. So 0, 0, pi -5, and then I'll have 2 pi 0, 3 pi 5, and 4 pi 0. I'm going to go ahead and dot this in. Make sure you don't do this solid because it's really not part of the graph. We just use it to help us. So there's 1 period. Let's do one more. I'm going to have a point down here, then at 0, then at +5, then back at 0. Again, we'll dot in that part of the sine curve. Okay, so I've got these 2 points up at the top. These are maximum values. I have these 2 points at the bottom. Those are minimum values. Then I have 1, 2, 3, 4, 5 points in the middle. I'm going to have an asymptote at every one of those points. So I don't need to draw one at the y-axis. We don't draw over the y-axis, but we need to remember there's one there. Then I'll have one at 2 pi. Since the sine is 0 at 2 pi, the cosecant is going to be undefined, and that's why we have this asymptote. It's undefined, so our graph will approach it, but it will never cross it. So there's 3, and then there's one more. Okay, now we've done all this work, and we haven't even drawn the cosecant curve, but now we're going to draw it. So looking in between my asymptotes, I see I have this U shape that opens up. So my cosecant is going to be a U shape that opens down and approaches the asymptote. Make sure you don't cross those. Here's my U shape that opens down. So my cosecant curve will open up, open down, and open up. So again, keep in mind that the green curves are actually the only part of the cosecant curve. Everything else is just to help us, but it is necessary to draw that in. I do want to see your asymptotes, and I do want to see the dotted sine or cosine curve when you graph this. Okay, so here's 1 period from 0 to 4 pi. Notice up here our period was 4 pi. Okay, and then another period from 4 pi to 8 pi. As always, if you have questions, make sure you write those down. Go on and complete the other 2 examples, and I'll have those solutions for you in class so that you can check. And we'll see you next time.